Sir William Lawrence Bragg CH, OBE, MC, FRS was an Australian-born British physicist and X-ray crystallographer, discoverer of Bragg's law of X-ray diffraction, which is basic for the determination of crystal structure. He was joint winner of the Nobel Prize in Physics in 1915, for their services in the analysis of crystal structure by means of X-ray, an important step in the development of X-ray crystallography. Bragg was knighted in 1941. As of 2016, Lawrence Bragg is the youngest ever Nobel laureate in physics, having received the award at the age of 25 years. Bragg was the director of the Cavendish Laboratory, Cambridge, when the discovery of the structure of DNA was reported by James D. Watson and Francis Crick in February 1953. Biography. Early years. Bragg was born in Adelaide, South Australia. He showed an early interest in science and mathematics. His father, William Henry Bragg, was elder professor of mathematics and physics at the University of Adelaide. Shortly after starting school, aged 5, William Lawrence Bragg fell from his tricycle and broke his arm. His father, who had read about Röntgen's experiments in Europe and was performing his own experiments, used the newly discovered X-rays and his experimental equipment to examine the broken arm. This is the first recorded surgical use of X-rays in Australia. After beginning his studies at St. Peter's College, Adelaide in 1905, Bragg went to the University of Adelaide at age 16 to study mathematics, chemistry and physics, graduating in 1908. In the same year his father accepted the Cavendish Chair of Physics at the University of Leeds, and brought the family back to England. Bragg entered Trinity College, Cambridge in the autumn of 1909 and received a major scholarship in mathematics, despite taking the exam while in bed with pneumonia. After initially excelling in mathematics, he transferred to the physics course in the later years of his studies, and graduated with first-class honours in 1911. In 1914, Bragg was elected to a fellowship at Trinity College. A fellowship at a Cambridge college involves the submission and defence of a thesis. Among Bragg's other interests was shell collecting. His personal collection amounted to specimens from some 500 species, all personally collected, from South Australia. He discovered a new species of cuttlefish, Sepia braggi, named for him by Joseph Virchow. Career work on X-ray crystallography. Bragg is most famous for his law on the diffraction of X-rays by crystals. Bragg's law makes it possible to calculate the positions of the atoms within a crystal from the way in which an X-ray beam is diffracted by the crystal lattice. He made this discovery in 1912, during his first year as a research student in Cambridge. He discussed his ideas with his father, who developed the X-ray spectrometer in Leeds. This tool allowed many different types of crystals to be analyzed. Work on sound ranging. Bragg's research work was interrupted by both World War I and World War II. During both wars he worked on sound ranging methods for locating enemy guns. In this work he was aided by William Sansom Tucker, Harold Roper Robinson and Henry Harold Hemming. For his work during World War I he was awarded the Military Cross and appointed Officer of the Order of the British Empire. He was also mentioned in dispatches on the 16th of June 1916, the 4th of January 1917 and the 7th of July 1919. On the 2nd of September 1915 his brother was killed during the Gallipoli campaign. Shortly afterwards, William Lawrence Bragg received the news that he had been awarded the Nobel Prize in Physics, aged 25. Between the wars, from 1919 to 1937, he worked at the Victoria University of Manchester as Langworthy Professor of Physics. He was director of the National Physical Laboratory in Teddington in 1937. After World War II, Bragg returned to Cambridge, splitting the Cavendish Laboratory into research groups. He believed that the ideal research unit is one of 6 to 12 scientists and a few assistants. work on proteins. In 1948 he became interested in the structure of proteins and was partly responsible for creating a group that used physics to solve biological problems. He played a part in the 1953 discovery of the structure of DNA, in that he provided support to Francis Crick and James E. Watson, who worked under his aegis at the Cavendish. Bragg's original announcement of the discovery of the structure of DNA was made at a Solvay conference on proteins in Belgium on 8 April 1953, but went unreported by the press. He then gave a talk at Guy's Hospital Medical School in London on Thursday 14 May 1953, which resulted in an article by Richard Calder in the News Chronicle of London on Friday 15 May 1953, entitled, "Why You Are You? Near a Secret of Life." Bragg was gratified to see that the X-ray method that he developed 40 years before was at the heart of this profound insight to the nature of life itself. At the same time at the Cavendish, Max Perutz was also doing his Nobel Prize-winning work on the structure of hemoglobin. Bragg subsequently successfully lobbied for, and nominated, Crick, Watson and Maurice Wilkins for the 1962 Nobel Prize in Physiology or Medicine. Wilkins' share recognized the contribution made by researchers at King's College London to the determination of the structure of DNA. Among those researchers was Rosalind Franklin, whose photograph 51 showed that DNA was a double helix, not a triple helix as Linus Pauling had proposed. Franklin died before the prize was awarded. The crystal structure of hen egg white lysozyme, which was sold by D.C. Phillips al. in 1965 under the directorship of Lawrence Bragg at the Royal Institution, London, led to the discovery of the helix. The lysozyme structure was determined from crystals of hen egg white lysozyme chloride, which belong to the tetragonal space group P2 with the unit cell dimensions A equals B equals 79.1a, C equals 37.9a and have one lysozyme molecule in the asymmetric unit. The existence of the helix, as opposed to Pauling's alpha helix, was predicted by W. L. Bragg, J. C. Kendrew and M. F. Perutz in 1950. Apparently, many workers failed to mention the discovery of the helix, and failed to acknowledge the part it plays in the lysozyme structure. Pauling never acknowledged that at least part of the above-mentioned 1950 paper made sense. Unlike myoglobin, in which nearly 80% of the amino acid residues are in the alpha helix conformation, in the lysozyme protein the alpha helix content is only about 40% of the amino acid residues in 4 main stretches. The helix is an earlier proposal for the structure of polypeptides made by Bragg, W. L., Kendrew, J. C. and Perutz, M. F. in 1950. It is based on the crystallographic idea of an integral number of residues per turn of the helix. In this conformation, every third peptide is hydrogen bonded back to the first peptide, thus forming a ring containing 10 atoms. Royal Institution. He had a long association with the Royal Institution, including Professor of Natural Philosophy, 1938 to 1953, Fullerian Professor of Chemistry, 1954 to 1966, Superintendent of the House, 1954 to 1966, Director of the Davy Faraday Research Laboratory, 1954 to 1966, Director, 1965–1966, Emeritus Professor, 1966 to 1971. In 1931, 1934 and 1961, Bragg was invited to deliver the Royal Institution Christmas lecture on the universe of light, electricity and electricity. He also introduced the school's lectures program during his time at the Royal Institution. Personal life: he married Alice Hopkinson in 1921, with whom he had 4 children: Stephen Lawrence, David William, Margaret Alice, born 1931, and Patience Mary, born 1935. Alice was on the staff at Withington Girls' School until Bragg was appointed director of the NPL in 1937. Bragg's hobbies included painting, literature, and a lifelong interest in gardening. When he moved to London, he missed having a garden and so worked as a part-time gardener, unrecognised by his employer, until her guest at the house expressed surprise at seeing him there. He died at a hospital near his home at Waldringfield, Ipswich, Suffolk. He was buried in Trinity College, Cambridge. His son David is buried in the parish of the Ascension Burial Ground in Cambridge, where Bragg's friend Rudolph Cecil Hopkinson is also buried. Honours and awards: Bragg was elected a Fellow of the Royal Society in 1921, a qualification that makes other ones irrelevant. He was knighted by King George VI in the 1941 New Year Honours, and received both the Copley Medal and the Royal Medal of the Royal Society. Although Hunter, in his book on Bragg Light is a Messenger, argued that he was more a crystallographer than a physicist, Bragg's lifelong activity showed otherwise. He was more of a physicist than anything else. Thus, from 1939 to 1943, he served as president of the Institute of Physics, London. In the 1967 New Year Honours he was appointed Companion of Honour by Queen Elizabeth II. Since 1992, the Australian Institute of Physics has awarded the Bragg Gold Medal for Excellence in Physics to commemorate Lawrence Bragg and his father, William Bragg, for the best PhD thesis by a student at an Australian university. Nobel Prize, Matteucci Medal, Hughes Medal, Royal Medal, Guthrie Lecture, Copley Medal. Winner of the Nobel Prize in Physics in 1915, for their services in the analysis of crystal structure by means of X-ray, an important step in the development of X-ray crystallography. Bragg was knighted in 1941. As of 2016, Lawrence Bragg, February 1953. Biography: early years: Bragg was born in Adelaide, South Australia. He showed an early interest in science and mathematics. His father, William Henry Bragg, was elder professor of mathematics and physics at the University of Adelaide. Shortly after starting school, aged 5, William Lawrence Bragg fell from his tricycle and broke his arm. His father, who had read about Röntgen's experiments in Europe and was performing his own experiments, used the newly discovered X-rays, and his Sir William Lawrence Bragg CH, OBE, MC, FRS was an Australian-born British physicist and X-ray crystallographer, discoverer of Bragg's law of X-ray diffraction, which is basic for the determination of crystal structure. He was joined with as the youngest ever Nobel laureate in physics, having received the award at the age of 25 years. Bragg was the director of the Cavendish Laboratory, Cambridge, when the discovery of the structure of DNA was reported by James D. Watson and Francis Crick in